Welcome to this episode of Robert's Creative Chronicles. So today we'll be solving this question, which states that find the center of gravity of an inverted T-section with flange 60 mm by 10 mm and web 50 mm by 10 mm. So solution. So first we have to draw the inverted T-section. So now this is the inverted T-section. Here is the flange. Here is the flange. And here is the web. So one thing I want you to know is that since we are finding the center of gravity of a T-section, we are going to only use one reference axis because there's one axis is already symmetrical. The y-axis is symmetrical. So we don't need to use two reference axes. We only use two reference axes if we cannot find at least one that is symmetrical. But here, this y-axis is symmetrical. So the center of gravity of this section will lie here. So we only need to use only one reference axis, which is the x-axis. So the x-axis, we can put it at the bottom here, or we can also put it at the top here, anywhere you want to put it. You still get the correct answer for center of gravity. So we'll put x-axis. X-axis is our reference axis. So then let's put the dimensions. So the question says that with flange 60 mm by 10 mm. So this is the flange. So here will be 60. Then here is 10. Mm and 60 mm. That's millimeter. Then here and web 50 mm by 10 mm. So web here also will be 50 mm by 10 mm. So this is 50 by 10, the web, and the flange is 60 by 10. So now we can proceed. So now we have to locate the center of gravity of these two shapes. This one will be my first shape. This one will be my first shape, and this one will be my second shape. So now we have to find the center of gravity of the individual shapes. So the center of gravity of this is here, and the center of gravity of this second shape is here. It's at the center. So now we'll find the area since we're using method of moments. So A1 for this first rectangle is what? Is 60 times 10, which is 600 millimeter square. It's millimeter square. Then in this one, unlike the unequal angle section that I solved in one of my previous videos, this one, we are going to only use y1 and y2. In the unequal angle section, we used x1, x2, y1, y2 because we're using two reference axes. So since I'm only using one reference axis in this one, it's only the distance from that reference axis that I'm going to take account. If it were two reference axes, you have to find the distances from those two reference axes. But this one is only 1. So and the distance from this reference axis is y. Since it's x, the distance will be y. So y1 from that is the distance from this centroid to the reference axis. This is what? 10 over 2, which is 5 millimeter. Then the second one, A2, is what? Is 50 times 10. 50 times 10, which is what? 500 millimeters square. Then we are going to find y2. y2 is the distance of the second shaped centroid from the reference axis. So this will be what? 50 divided by 2 plus 10. So this will be 50 divided by 2 plus 10. So it will be what? Y2 is 50 divided by 2 plus 10, which is 25 plus 10, which is what? 35 millimeters. So now it will be, since here is 10, then 18.6 will be somewhere here. Somewhere here. So at this point, we'll call it G. So we'll call this point G. So this will be our center of gravity. So this will be the center of gravity of this inverted T section. So it will say 8.6 millimeter from the bottom of flange. We'll say it's 8.6 centimeter from the bottom of flange, from the bottom of this flange going up. So this is it. This is how you find the center of gravity of an inverted T section. I hope you understood this episode. If you have any question, feel free to contact me using my WhatsApp or email written in the description below, or you can write them in the comment section. Thank you for watching. Please don't forget to like, share, and subscribe to my channel, and hit the notification bell to get notified as soon as I drop a new video. Thanks.